Hello, Matt here from chemistrystudent.com. In this video, we're going to look at calculating moles and masses. We're going to talk about what mass is, its connection to moles, and how to calculate the moles of a substance in a sample using mass and molar mass, with examples given. Before we talk in detail about mass and moles, it is essential you are comfortable with the idea of the mole. The mole, as well as other mole-based calculations, have been covered in separate videos. Check the links in the description below. As a quick refresh for this video, however, the mole is a term used to describe 6.022 times 10 to the 23 of something. The value 1 mole refers to is known as Avogadro's constant and comes from the number of atoms in a sample of an element that has the same mass value as the element's relative atomic mass. For example, hydrogen has a relative atomic mass of 1, meaning in 1 grams worth of hydrogen there are 6.022 times 10 to the 23 hydrogen atoms. Carbon has a relative atomic mass of 12, meaning in 12 grams worth of carbon there are 6.022 times 10 to the 23 carbon atoms. Balanced equations in chemistry are based on the molar ratios of reactants and products. For example, 2Na plus 2HCl to form 2NaCl plus H2 means 2 moles worth of sodium atoms reacts with 2 moles worth of HCl molecules to form 2 moles worth of NaCl and 1 moles worth of hydrogen gas. Recap done? Let's go. Mass is a measurement used to describe how much matter something is made up of. In chemistry, we know that matter comes from atoms, and therefore when we measure the mass of something, what we are really measuring is the total mass of all the atoms present in the sample. As atoms of different elements can all have different masses, the overall mass of a sample doesn't really give us much useful information about how many atoms or molecules there are in it. For this, we also need to know the mass in grams of 1 mole's worth of atoms of each element in the substance. This value is called molar mass, and rather usefully, is the same value as an element's relative atomic mass. They aren't, however, the same thing. Relative atomic mass has no units, whereas molar mass does. It has the units of grams per mole. For example, the relative atomic mass of hydrogen equals 1, and this means the mass in grams of 1 mole's worth of hydrogen atoms is 1 gram. The molar mass of hydrogen, then, is 1 gram per mole. We can't directly measure how many atoms or molecules are present in a sample, as they are too small to count. However, if we know the molar mass of an element or compound, we can use this and the total mass of the sample to find the moles of atoms or molecules in it. If the molar mass of a compound or element equals grams per mole, then that means molar mass equals mass in grams divided by moles. If we wanted to find the moles of a compound or element in a sample, we can rearrange this relationship, and this gives moles equals mass divided by molar mass. For example, 12 grams of carbon contains 1 mole of carbon atoms. Its molar mass is 12 grams per mole. 12 grams divided by 1 mole. Rearrange this and we can see 1 mole of carbon equals 12 grams, mass of sample, divided by 12 grams per mole, molar mass. The moles of carbon atoms in a sample of 6 grams then equals 6 grams, mass of carbon sample, divided by 12 grams per mole, carbon's molar mass, giving 0.5 moles. As relative atomic and relative molecular masses have the same value or number as molar masses, we often just write Ar and Mr in the equation, as mathematically the value is the same as molar mass. The units for mass have to be in grams, as this is the unit used in molar mass. This same relationship between Mr, mass, and moles can also be used to calculate the mass of a given number of moles of an element or compound. If we know the moles of a substance and its molar mass, we can multiply them together to find the mass that this number of moles would have. For example, 1 mole of water, H2O, has a mass of 18 grams, as its relative molecular mass is 18, meaning its molar mass is 18 grams per mole. 2 moles of H2O then would have a mass of 36 grams, as 2 times 18 equals 36. Mass equals moles times by mR. A key skill in chemistry at this level is to be able to determine the mass of a product that can be formed based on the masses of reactants reacting. By using a balanced reaction equation, if we know the mass of a reactant reacting, we can find the moles that are reacting and then use the molar ratio of substances in the reaction equation to find the moles of product formed, and then use this to find its mass. Remember, the ratios used in a balanced reaction equation are molar ratios. For example, if 10 grams of copper-2 oxide reacts with carbon monoxide completely to form copper and carbon dioxide, the moles of copper-2 oxide reacting equals mass, 10 grams, divided by mR, 79.5, giving 0.1257861 moles. The balanced equation shows us the molar ratio of copper-2 oxide to copper is 1:1. For every 1 mole of copper-2 oxide that reacts, 1 mole of copper is produced. This means if 0.1257861 moles of copper-2 oxide is reacting, 0.1257861 moles of copper should be produced. The mass of this many moles of copper can be found using mass equals moles times molar mass. The moles is 0.1257861 and the relative atomic mass of copper is 63.5, meaning its molar mass is 63.5 grams per mole. 0.1257861 times 63.5 equals 7.99 grams of copper. So, to summarize, the molar mass of an element is the mass in grams of 1 mole's worth of its atoms. By using a substance's molar mass, we can convert between mass and moles to describe how much of the substance we have. If molar mass equals grams per mole, then that means it can be calculated using mass in grams of a sample divided by the moles of it. If we wanted to find the moles of a substance using mass, then we can rearrange this and get moles equals mass in grams divided by molar mass. Equally, mass of substance in grams equals molar mass times moles. As a substance's relative atomic or molecular mass is the same value as its molar mass, just of a different unit, we often just write AR and MR in the equation, as mathematically the number they refer to is the same as molar mass. Using a balanced reaction equation, if we know the mass of a reactant reacting, we can find the moles that are reacting and then use the molar ratio of substances in the reaction equation to find the moles of product formed, and then use this to find the mass of product that would be produced. The ratios in a balanced reaction equation are molar ratios. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.